Welcome to another video on my hydraulics set, which is by now more or less controlled by fischertechnik robo interface, and of course this is all fischertechnik. Last time I made a reconstruction to decrease the speed with which this chain is being moved, but changing the speed is not the solution. Changing the power as well is part of the solution, which was not possible. So I have now received this motor, which still should be getting two wires soldered here. Then this plate goes on this side. Then these wires will be replaced by a part of this wire, and then hopefully things will work out, but I need a major reconstruction here. So let's get started, and first prepare this motor. Alright, now I have modified this motor. Two wires soldered to the ends and two connectors. So that is all set. And what I've got to take with me is a connecting part between these and the wires that lead to the board. But that's just a detail, or maybe they're long enough to actually connect directly to the board. Anyway, another thing that I just noticed is that with this part of the hydraulics, and you can see that it still works, but in the present situation it won't work, because halfway it takes on with the height of this piston, and when I take it out, and it is not even fully filled with water, I now notice, so I need to refill somehow with this distilled water. But when I fully take on, that is not going to work. So at this point it should be here, and it will never have, so the chain should go here somewhere. I need to lengthen the chain or lift it up. Most likely somewhere here. So on this point, hard to see, so maybe here. Is this better? Watchable? Hardly. Anyway, here, and then up to here. So something has to be done with the chain. Probably more length. So first let's do the motor, which also has to be brought. The motor which also has to be brought forward, because now it is reconstructed more to the end because of this wheel and the axle. So let's see how that works out. Right, first thing, rewiring with a couple pieces in here. So let's see, and full speed ahead. So this goes much slower. But let's see it from here. Yes, much slower. Then about the level of the water. There may have been some water lost, but the majority of the water is in the tube. So the question is, do I fill it up? No, I will not fill it up. There's some gas in it. I'm fine with it. So now time for the big reconstruction, in which I bring this motor forward and remove the big gear. Let's see how that ends up with this extra chain part. And I'm not going to lower it, I'm just keeping this whole thing up. Right, so now after reconstruction it's rather lean, as you can see. Just one long chain, beginning and end point. So this is nice with respect to the piston, and speed is alright. Let's check this out. And this is where it should end somehow, and this is also where it should end. So this is too high, this is too low, this is the starting point somehow. And this is the end. So it's rather narrow, but that's the way it is. And so this is the total view now. And the question of course now is, how do I connect this to the chain? Which was of course the first question I had, but at least now the motor has the power to drag it along. So let's see if that indeed works out. So the question is not just how do I connect the piston to the chain, but also how do I make it stop once it has reached its high point, because the chain goes on and the piston certainly doesn't. So I have placed two sensors contacts, and this contact certainly shows it has reached the point, and this contact isn't wired yet, but let me just, right, that doesn't work yet, of course, obviously, so let me do it by hand. And here you see it being pushed up, so it has reached its high point, at which point and moment the motor should stop. Nice, but I have to connect it still to the chain. So I can easily remove this one and focus on the connection with the chain. But this one is certainly solved. That's for programming, which is then of course digital input. So let me already put it in. I think it's called digital 1. If T digital 1 is 1, then T dot set motor is stop, obviously, or go to the reverse, and that should also be valid for if T digital 2 is 1, then T set motor well, let me just make it right away. Right, no, small r is, I don't care, I don't know, 0, and this one can go the other way. Let's make this speed 1 and speed 1. Not tested, obviously, but it's the way it should be done. Alright, now there is another point. I didn't find any option to connect it to the chain, since it is intended to be used for a conveyor belt. But I found another example of use with the worm gear, and if I replace the chain by this worm gear, I can easily fit it in and connect it and have it moved up and down. So I think I'll abandon the whole chain idea and next time reconstruct it with this motor being placed vertically to fit into this one somehow. Should not be too hard, and then have it done that way. So I think that's a very nice solution. Why make it very difficult if possible when you have an easy solution? So yeah, and then of course these switches, one still to be wired, can be used anyway. So this works manually, and soon this will work computerized, robotized. So well, thank you for watching. One thing that won't work and one thing that presumably will work: switches to determine what's the status, and some soldering and rewiring with the other motor. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion, and you can also follow me via Instagram and Twitter. Comments and suggestions will be very highly appreciated. You can show your support by making a donation via either PayPal or Wired, and you can also become a patron, and depending on the pledge you make, have your name mentioned on my website and with my videos. More information under this video URL of my website, and you can also see it everything in the next short segment. Going to be continued. Have a nice day and bye bye.